Question 664. We're gonna evaluate this definite integral, and we need to apply the integration technique called the integration by parts. The formula for the integration by part is integral 𝑢𝐺𝑣 is equal to 𝑢𝑣 minus integral v du. The key to integration by parts is to choose u and dv correctly. We're gonna use 𝗖𝗨𝗨𝗏 rule for selecting u. So 𝗖𝗨𝗨 rule. This shows the order of preference when deciding which function to assign u to. I stands for inverse trig. Inverse trig, like inverse sine or inverse tangent. L stands for log. We have usually natural log, right? ln. A stands for algebraic. Algebraic functions, like polynomial functions. We can say polynomial. Like x squared, x cubed, like that. T stands for trig, sine or cosine or tangent. E stands for exponential functions. Usually we have e to the x, right? We can set the function on the left with u. For example, this indefinite integral has algebraic function and trig function, right? So we have a and t. So among these two functions, a is on the left, right? Then we're gonna let a function be our u. Okay? Now let's try to solve this indefinite integral. We're gonna erase this. We're gonna let x be our u. So u is equal to x. Then sine 2x dx must be dv. If some function is u, the leftover is dv. Okay? So write dv right here. That's sine 2x dx. Okay? Now we have to find du, right? Differentiate this equation to find du. Du over dx is equal to 1, right? So du is equal to just the dx, right? We differentiate from this equation right here. And we have to find v now. V is equal to, we have to actually integrate. We have to find the antiderivative of sine 2x, right? So antiderivative of sine 2x, that's negative cosine 2x times 1 over 2, right? So use the formula to write this indefinite integral. So this indefinite integral is equal to uv. U is x, v is negative 1 over 2 cosine 2x minus integral v du, right? So v is negative 1 over 2 cosine 2x times du is just the dx, right? So that is equal to negative x over 2 cosine 2x plus integral, actually 1 over 2 times integral cosine 2x dx, right? So that is equal to negative x over 2 cosine 2x plus 1/2 times, what's antiderivative of cosine 2x? That's 1/2 sine 2x, right? 1/2 sine 2x. Now we have to add c, right? So finally, let's write the antiderivative right over here. So finally, that is equal to negative x over 2 cosine 2x plus 1 over 4, 1/2 times 1/2, right? Sine 2x plus c. That's our antiderivative of this integrand right here. There is another way to find the antiderivative of this indefinite integral. That method is called Tabular's method. Okay, and this method only works when our u is algebraic function or polynomial function. So in this case, our u is equal to x, algebraic function, right? So we can use Tabular's method to find the antiderivative. Here is how we use the method. So write u on the left hand side. So write x right here. And write dv on the right hand side. So sine 2x on the right hand side. We don't have to write dx. Okay? We're going to differentiate this function until we have a 0. So differentiate. We're going to integrate. We're going to find the antiderivative on the right hand side. So integrate. Okay? Derivative of x is equal to 1. Derivative of 1 is equal to 0, right? We're done. Okay, antiderivative of sine 2x, that's negative 1 over 2 cosine 2x. Antiderivative of negative 1 over 2 cosine 2x, that's negative 1 over 4 sine of 2x, right? Now we multiply terms like first term on the left column, second term on the right column, just like this. And the sign starts from positive, so this is positive. Next, second term on left column, third term on the right column, just like this. That's negative. Okay, sign alternates from positive to negative. The next one is positive, right? But next one, we don't have to do that because we have a 0, right? 0 times whatever term right here is going to be 0, right? So our answer is equal to x times negative 1 over 2 cosine 2x with a positive. So that's going to be equal to negative x over 2 cosine 2x plus 1 times negative 1 over 4 sine 2x. But it's negative with a negative, okay? So negative times negative gives us positive, right? So positive plus here. 1 times 1 over 4, that's 1 over 4 sine of 2x. We're done. Now we end up with a constant c. Okay? Question 668. This indefinite integral has algebraic function and logarithmic function, right? Using 𝗖𝗨𝗟𝗨𝗦 rule, we have algebraic function and logarithmic function. So we're going to let u is equal to this logarithmic function, right? So let's try this. So let u is equal to natural log 2x plus 1. dv is equal to x dx, right? If natural log is u, then x dx, that's dv. And remember, the integration by parts is, u dv is equal to uv minus, v du, right? That's our formula, right? So let's find du and v. Here, du is equal to derivative of natural log 2x plus 1. That's 1 over 2x plus 1 times derivative of 2x plus 1, right? So times 2 dx. All right? What's v? If we find the antiderivative of x, that's going to be x squared over 2, right? So using the formula, this indefinite integral is equal to uv, right? uv. That's going to be natural log 2x plus 1 times x squared over 2 minus integral v du. Integral v x squared over 2 times du is 2 over 2x plus 1 and dx, right? So that's going to be equal to, here that's x squared natural log 2x plus 1 over 2 minus integral, this one cancels out, x squared over 2x plus 1 dx, right? Now we have to find the indefinite integral right over here. This is in fraction form, but when we look at this fraction form, we have a higher degree in our numerator. This is x squared, this is just the x, right? Then what we have to do is we got to do long division first and then find the antiderivative of this expression, right? So let's do that. So x squared divided by 2x plus 1, but I'm going to write 1/2 in front of integral. Then let's erase this. This is going to be equal to x plus 1 over 2, right? So 2 times x gives us 2x. 2 times 1 over 2 gives us 1, right? So that's x squared divided by x plus 1/2. X plus 1/2. So x times what gives us x squared? That's x, right? So x squared, 1/2 times x, that's plus 1/2 x. Subtract it. So x squared minus x squared, that cancels out. We have a negative 1 over 2x here. And x times what gives us negative 1/2 x? That's minus half, right? So x times negative negative 1/2, that's negative 1/2 x. 1/2 times negative 1/2, that's negative 1/4. Subtract it. So that gives us positive 1 over 4, right? So remainder is positive 1 over 4, right? So we can rewrite this expression. X squared natural log 2x plus 1 over 2 minus 1 over 2 integral. This is going to be quotient x minus 1 over 2. Remainder is positive 1 over 4, right? So plus 1 over 4 x plus 1 over 2, right? So let's find the antiderivative of that. So we have x squared natural log 2x plus 1 over 2 minus 1 over 2. Antiderivative of x is x squared over 2 minus 1 over 2x plus 1 over 4 natural log x plus 1/2 plus c, right? Now we're done. Question 686. If integral f of x sine x dx is equal to negative f of x cosine x plus 10 times integral x to the 4 cosine x dx, then what is the function f of x? Remember, indefinite integral u dv is equal to uv minus integral v du, right? When we look at this integration by parts formula, here we have same function, right? U and u. Since we have f of x here and f of x here, we can let u be f of x, right? So u is equal to f of x, then sine x dx is our dv, right? So write dv is equal to sine x dx. Then du is equal to derivative of f is just f prime x, right? Times dx. v is equal to antiderivative of sine, which is negative cosine. So this indefinite integral f of x sine x dx can be written as uv f of x times negative cosine x. That's negative f of x cosine x minus integral v du. V is negative cosine, du is f prime x dx, right? So negative cosine x times du f prime x dx, right? So let's simplify this. So that is equal to negative f of x cosine x, negative times negative, that's positive integral. Let's write f prime first. F prime x cosine x dx, right? And all of this expression, all of this thing is equal to this, right? Here we have negative f of x cosine, negative f of x cosine, right? Here we have cosine, cosine. Here we have a 10x to the power of 4, right? That must be equal to f prime of x, right? So we know that f prime of x is equal to 10 times x to the power of 4. And the question is, what is the function f of x? So f of x is antiderivative of f prime, which is equal to 10x to the power of 4. So 10 times x to the power of 5 over 5. So that is equal to 2x to the 5. So our function f of x is equal to 2x to the power of 5. The table above gives values of f prime, g, and g prime for selected values of x. If definite integral f prime g dx is equal to negative 2, then what is the value of definite integral from 0 to 1 f g prime x dx? Integral u dv is equal to uv minus integral v du, right? That's the formula for the integration by parts, right? If this is definite integral from, let's say, a to b, then this must be uv from a to b, and this definite integral must be from a to b, all right? So in this case, we're going to let u is equal to f of x. Then our dv must be equal to, this is our u, right? The rest of the expression must be dv. So dv is equal to g prime of x dx, right? Then our du is the derivative of f prime of x dx, and our v is antiderivative of g prime. That's a g of x, right? So this definite integral is equal to uv f of x gx, f of x gx from 0 to 1 minus integral v du, right? So g of x times f prime of x dx. So that is equal to, we're going to have to substitute 1 for x, f of 1, g of 1 minus f of 0, g of 0 minus integral g of x times f prime x. Well, that's actually negative 2. It's given right over here. Integral from 0 to 1 f prime x times g of x dx. That's negative 2, right? So let's just write negative 2 here. Okay, so what's f of 1 and g1? It's given right in this table, right? So when x is 1, f of x is equal to negative 2. So negative 2 times when x is equal to 1, g of x is 2. 2 minus f of 0. When x is 0, it's 4. When x is 0, g of 0 is negative 1. We have a plus 2. So that's going to be negative 4 plus 4 plus 2. So this is 0. 0 plus 2. The answer must be 2. Right?